Welcome to the BackSpace Academy lab on creating a highly available and fault-tolerant architecture for web applications inside a VPC. This lab will be the culmination of many aspects that you've learned throughout the course. The focus will be on making sure that you fully understand all of the concepts that are essential for certification. The architecture that we'll be developing will be typical of what you'd expect from, say, a WordPress application or an e-commerce site like Magento. So we're going to start off by creating a VPC in a single availability zone with private and public subnets. We're then just going to expand that to a second availability zone and create a DB subnet group. Within that, in that private subnet, we will create an RDS Aurora cluster, and that will be across multi-AZ. So we're going to have an RDS Aurora standby instance there, and we're also going to create an RDS Aurora replica to take some of the load off our RDS, the read load off our RDS master database. To allow those databases to get updates through to the internet, we're going to have a NAT instance there. And that NAT instance will connect up through to an internet gateway to allow that to happen. Our internet-facing traffic will be handled through an elastic load balancer, and that elastic load balancer will distribute traffic across an auto-scaling group of EC2 instances that will contain our WordPress application. We'll also have for our static assets and also for our latest code that we're going to bootstrap into our instances on startup, we'll have an S3 bucket there, and that will connect into our VPC through an S3 VPC endpoint, which is a new feature of VPC. So this architecture that we're going to create would serve as the building block for a much bigger architecture. For example, here we would use Amazon Route 53 to distribute our traffic across multiple copies of this architecture, depending on the geolocation of your end user. So the way that would work is we would create our VPC architecture there on the left in a region, and then we would use CloudFormer to create a copy of that architecture. Once we have done that, we can then look at replicating our data across to that new architecture. Now, because our static assets are going to be located in an S3 bucket, we can use the new capabilities of cross-region replication for S3 to create an S3 replica in that new region. The same with RDS Aurora. It has cross-region capability. And so we can actually create a cross-region read replica of our RDS Aurora instance and have that located in our new region. And that will speed up our reads for that database significantly and reduce the latency for that end user. The same, we would have a CloudFront distribution that will be fronting our S3 bucket. And that CloudFront distribution will deliver with the minimum latency to an edge location closest to your end user. So that's how that would work on a cross-region scenario. We could also take that one step further and again use CloudFormer to create a replica of that new architecture that we've created, and then use CloudFormation to launch that in multiple regions. So then we would have a global architecture that will be fronted with Route 53 to distribute that traffic to the least latency or to the best geolocation. And we'd also have that CloudFront distribution, again, distributing with the minimum latency for your end user. Okay, so the first thing we're going to do is to use the VPC wizard to create a VPC with public and private subnets inside a single availability zone. We're going to use the VPC wizard simply just to speed up the process for us. It does a lot of things for us that makes life a little bit easier. But the VPC wizard's not perfect for every application. So we're going to have a look at and fully understand exactly what the VPC wizard has done, and to modify what the VPC wizard has done for us as well, and to make any improvements that we need to make. So the VPC wizard is going to create those public and private subnets. It's also going to create a NAT instance for us. It'll create an internet gateway for connection through to the internet. And it will also create VPC endpoints for us to directly connect through from our VPC to an S3 bucket without having to go through our internet gateway and back through to our S3 bucket. This is a new feature of VPC, and does save a little bit of time as well. So we're just going to start off now at the VPC console, and looking at the VPC dashboard here. There's already, with a brand new account, which is what we've got here, we've been set up just purely and simply for the lab. We can see also already that we've got a VPC created for us. There's also subnets, access control lists, security groups, and a few other things there that are already been created for us. And so that is our default VPC. So we can see here, default VPC, yes. And it's in that CIDR block there, 172.31.00. And let's have a look at the subnet. So we've also got 4 subnets there also that are in that VPC, and we can see here default subnets, yes they are. And the same with the route table as well. And there's also an internet gateway there that allows us to connect from our default VPC into the wider internet. So we're not going to use a default VPC, we're going to use a VPC wizard. So let's start by clicking on Start VPC Wizard. And just to make sure that we're also in the US East region as well for this, so we can all be working off the same region, will be good. So first of all, we select VPC with public and private subnets. So we're going to call this VPC BackSpace-Lab. We'll leave the CIDR block at 10.0.0.0/16. We're also going to be creating a public subnet, so that's fine, we'll leave that there. And the availability zone we'll use for this is US East 1A. We'll call our public subnet 1. And when we create our second availability zone, we'll call that public subnet number 2. So on our private subnet, again, we'll leave that CIDR range the same. And the availability zone will be US East 1A. And again, we'll call that private subnet 1. And here it's asking the details of our NAT instance. So we'll lose something that's quite small there, M1 small. We'll select a key pair for that instance. If you don't have a key pair, you'll need to go into the EC2 console and create a key pair if you don't already have one. Now we've got here add endpoints for S3 to your subnets. So this allows us to create a VPC endpoint that allows direct connection from our VPC to an S3 bucket. Normally we would have to actually go out through to the internet gateway to get access to that S3 bucket. In this situation we can access it directly just by doing that. So we will select public and private subnets to create VPC endpoints for both our public and private subnets. And we're going to give that full access. And we'll leave everything the same as it is there, and we'll click on Create VPC. Okay, and thanks to the magic of pre-recorded video, we have a VPC successfully created there. So we'll just click on OK and have a look at it. So there is our default VPC, and here is our new BackSpace-Lab VPC. So having a look at that there, we have a route table that's been defined for us, and a network access control list also. Let's go into subnets on here. And here we can see we have our private and our public subnet. Okay, so let's have a look at our private subnet first. So we can see that we've got here, it's inside that VPC, not a problem there. We have a route table here, so let's have a look at that route table. Let's click on the route table tab here, and we can see here we've got a route for our local traffic. And we've got one here that's going to a VPC endpoint. So that is the VPC endpoint for our traffic that's going through to our S3 bucket or through to the S3 service. Also here we have traffic that's going out to the wider internet is going through an elastic network interface. And that elastic network interface is attached to our NAT instance. And we have a network ACL there that is allowing all traffic inbound and outbound. So we will look at tightening that up later on. We will have a look now at our public subnet. So again, we've got our, it's inside our VPC. We have a route table here and a network access control list. So looking at that route table here, it looks identical to the private subnet, but there is one difference here. So we've got the local traffic here, we've got the VPC endpoint for the S3 service, but here our external traffic to the wider internet is going through an internet gateway. Okay, so that's a difference. So in our public subnet, we're connecting through to an internet gateway. Our network access control list is the same, so allowing all traffic in and all traffic out. We can also see here that we have our existing default internet gateway, and we have our new internet gateway, which is inside our VPC for BackSpace Lab. And we can also see here that we have an elastic IP. Now that elastic IP is connected to the ENI for our NAT instance. Okay, so let's just jump back into subnets and have a bit of a closer look at the public and private subnets that have been created by the VPC wizard. So clicking on the private subnet number 1 here, and we've got the route table there, and let's have a closer look at that route table that's been associated with this subnet. So clicking on that there, the route table, and then select it from the list here. And let's go to Subnet Associations tab here. So it's actually associated to private subnet number 1. But here it says you do not have any subnet associations for this route. Okay. But we know that it is actually associated. So we can see here the following subnets have not been explicitly associated with any route table, and therefore are associated with the main route table. So because we haven't explicitly associated a route table to this private subnet, the main VPC rate table is automatically associated to that. And that's what's happened here. So if we have a look at, if we go back to subnets, have a look at our public subnet, and again click on the route table there, and select it from the list, we can see here that we have an explicit association up the top here between the route table and our public subnet. Okay, so here we can see that's an explicit association, whereas the other one down the bottom here was an implicit association. So we didn't explicitly associate it, so that was implicitly associated. So that's the difference between the two there. Okay, so we'll just have a look now and put it in perspective with the architecture diagram that we've got here. So the VPC wizard created an internet gateway for us to allow connection through from our public subnet through to the wider internet. So that's what we've got here. Okay, it created a NAT instance for us. It created VPC endpoints for us. Did these two public subnets, these two subnets, a public subnet and a private subnet inside a single availability zone here. So having a look at our public route table that has been explicitly associated to our public subnet. Okay, so we can have here a local route for local traffic. We've also got here our VPC endpoint for our S3 service. So that allows us to connect directly through from our public and our private subnets through to an S3 bucket without having to go through the internet gateway and then back out and in again from our S3 bucket. So that's really what we're looking at there. And with our public subnet, to connect to the wider internet, we have a route through to the internet gateway, and that's what we've got going on there. Now we have the VPC main route table. Now that is implicitly associated to the private subnet, and it will be implicitly associated to any subnet that doesn't have a route table explicitly associated to it. So the first one, again, we've got our local traffic route. We have our VPC endpoint for the S3 service. And what's different here is we have, for traffic going out to the wider internet, it will be going through to the elastic network interface of our NAT. So that's what's going on here. So we have here our private subnet is connecting in to our elastic network interface of our NAT. And that NAT will be connecting through our public subnet out through to our internet gateway. Okay, so now we'll just have a look at the NAT instance that was created for us by the VPC wizard. So to do that, we need to go to the EC2 console. So just jump into the EC2 management console, and we can see there we've got one running instance. So we'll click on that. Okay, so there we can see we've got our M1 small instance, which is in our, which is inside our VPC. So let's have a look at that. So there are a couple of things to notice here with this. The first thing to notice is that the virtualization type is paravirtual. So long-term support for the paravirtual instance type or virtualization type is not there by Amazon Web Services. So they do recommend to use the HVM virtualization type. So most of the new instances that are coming out are using HVM type, so it's good to for long-term support to use a HVM type when you're using instances. The other thing to have a look at here is that there is also a security group attached to that, so we can see here. We'll have a look at that security group, and we'll view the rules of that security group. Okay, so inbound, all traffic, outbound, all traffic. So that's not recommended for what we would want. We'd want to tighten that up quite considerably. So we'll look at creating a NAT, a specific NAT security group for our NAT. We'll also look at replacing this NAT instance for a NAT instance of HVM virtualization type. Okay, so to do that, we need to detach our elastic network interface that's connected to our NAT. So again, looking at our NAT here, we can see that there will be an ENI connected to that. So first of all, we'll have a look at our public IP. So here's our public IP here, or elastic IP. So there's our elastic IP, and we can see it's connected to that NAT instance inside our public subnet. So let's have a look at that elastic network interface that is attached to here. So we're going to want to actually detach this elastic network interface from our NAT instance, and then terminate our NAT instance, and then reconnect this elastic network interface to a new NAT instance. Okay, so the first thing that we're going to want to do is to make sure that when we terminate our NAT instance, we don't lose our elastic network interface that's attached to that network, to that NAT instance. So Let's go into Actions, and we look at Change Termination Behavior. So here it has Delete on Termination, so we don't want that, okay? So we make sure that we uncheck Delete on Termination, and we save that now. Okay, so now that we've actually made it so that we can terminate our net instance, and then this should still be available to use. So let's go into our instances, and here we can see our net instance, and we will terminate that. So and let's terminate that. Okay, so our net instance is now terminated. So let's go back into our network interfaces. So click on Network Interfaces. And here we have our Elastic Network Interface that was previously attached to that instance, and it no longer is. And it's available now. So it doesn't have an instance ID here. So it's not connected to an instance, and it's available to be attached to another instance. Okay, so when we're ready to go, we can actually grab this Elastic Network Interface along with its public IP and attach it to a new NAT instance. So before we do that, we need to create this new security group. So we go into Security Group, and we're going to create a NAT security group specific for a NAT. So create security group. Okay, so we're going to call this NATSG, our security group. Give it a description there, NAT security group. Make sure that we select the BackSpace-Lab VPC. Then we're going to click on Add Rule and start adding our rules to this, our inbound rules to the security group. Okay, so the first rule we're going to create is for port 80. And that's going to be for inbound from our private subnet, so 10.0.1.024, and the same for port 443 access. That's going to be coming in from our private subnet. We also want SSH in on port 22, and that's coming from us. So we want to put my IP in there, and it will populate that field with your own IP. Okay, so now we'll click on the outbound, and we'll add the outbound rules that we require as well. So again, we're going to need port 80, and that's going to be for everywhere. Okay, so and again the same for port 443 for everywhere. And click Create. Okay, so the next thing we're going to want to do is to create another rule using our new security group ID. So we're just going to copy that security group ID. And we're going to put another inbound in here. And that's going to allow all traffic from that security group. And there's our NAT security group. So everything from that's inside this NAT security group will be allowed. And we'll just save that as well. Okay, so now that we've created our NAT security group, we're going to go back into our network interfaces. And we're going to actually assign that security group to our Elastic Network Interface. So let's go into Actions and change security groups. And here you can see it's attached to the default VPC security group. We're going to change it so it's associated with this NAT security group. Okay, and that's done. Okay, so we've covered quite a bit there. So we'll look at right now, just recapping on the difference between a security group and a network access control list. And this must be quite well understood if you're going to go through to the certification exam. You need to clearly understand the difference between a route table, security group, network access control list, and the like. So first of all, a security group, it operates at the instance level, and it's a first layer of defense. It is a firewall, okay? It operates at the instance level. A network access control list, it operates at the subnet level. A security group, it allows rules only. It supports allow rules only. A network ACL supports both allow and deny rules. Now also, a security group is stateful, okay? It responds to traffic, okay? So return traffic is automatically allowed regardless of any outbound rules. So it is stateful. It will automatically allow response and return traffic to go out. So in contrast, we have a network ACL that is stateless, okay? So return traffic must be explicitly allowed by the rules. It doesn't just automatically allow return traffic. Okay, so you need to have both inbound and outbound rules to allow that return traffic. In a security group, we evaluate all rules before deciding whether to allow that traffic. If there is more than one rule for a specific rule, we apply the most permissive rule. The most permissive rule, not the most restrictive rule. Okay, so if you have something that is more broad, a CIDR block that is more broad, the more broad and less permissive rule will prevail. Okay. In contrast, a network ACL is that we process rules in number order when deciding whether to allow that traffic or not. And the most restrictive deny applies. Okay. Not the most permissive, the most restrictive deny applies with a network ACL. In a security group, this applies to an instance only if someone specifies a security group when launching that instance, or associates a security group with the instance later on. In contrast, with a network ACL, it automatically applies to all instances that are located in the subnet it's associated with. It's a backup layer of defense, so you don't have to rely on someone specifying a security group. So any instance that is launched within this private subnet here will be associated with the network ACL for that private subnet. Okay, so that brings us to the end of the first part of this lab. So in the next lesson, we'll look at creating a